And then before we get started, I am going to also do just kind of a little quick level setting of kind of the basics of machine learning for those of you who aren't as familiar, just to kind of do some really simple level setting, all right? So that's how we'll get started, and that's what I want to cover today. All right, let's start by talking about what exactly is supervised machine learning and how can you benefit from it. And so one example of supervised machine learning that I like to give is being able to predict the price of a home. All supervised machine learning is doing at the end of the day is you have something that you want to predict, so it helps you make predictions. So I have something that I want to predict, say the price of a home, and that's called my label, all right? And then I have a whole bunch of things that influence that thing that I'm trying to predict. All right, and those are my features, my feature set. So, for example, things that might affect the price of a home are things like the square footage of the home, or the zip code, the location, right? Different houses in different locations, even with the same square footage, may cost different in different areas. And then there's going to be a lot more data than that. It's usually, real life is messy, so it's usually a lot more than just 2 columns. So number of bedrooms, number of bathrooms, maybe the size of the master bathroom, because for some reason people really seem to care about that. Maybe the number of years since the kitchen has last been remodeled, whatever. So there's a whole bunch of features that would feed into that. And then all supervised machine learning is doing is using crazy beautiful math to find the correlations between those features and that label. All right? And then the kind of crazy beautiful math that it's doing depends on which algorithm you use. So there's a number of different algorithms. You guys may have heard things like linear regressions, to Bayesian networks, to decision trees, to neural nets. So there's lots of different ways to do the math, and different types of math work better for different problems. All right? So that's what we're going to talk about today and see how to do some of those things. All right, and then the thing that's cool then is, so I train my model based on a labeled data set like this. So I have a whole bunch of data that says, okay, for these features, that was the label. I train my model based on that and use the math to build a model. And then what I can do once I built that model is I can use the model and hand it new data, say, okay, now that I have that model, for this square footage and zip code and so on, what should the price be? And based on those relationships it's found, it can predict the price for me. All right, so that's all supervised machine learning is doing. Okay, so moving forward, there's a whole bunch of different kinds of machine learning algorithms. Azure machine learning specifically supports 25 different machine learning algorithms. And then within it, it actually supports 4 different categories of algorithms. And then there's 25 within those 4 categories. I spoke about supervised machine learning. So the first 3 are all examples of supervised machine learning. So let me explain the difference between them. Classification is when you are trying to predict discrete categories, all right? So discrete buckets of information. So who is my husband lying or telling the truth? Discrete buckets. Is this team or that team going to win the sports game? What's rugby? Is rugby big here? What's the? Okay. Oh, okay. Sorry. If it makes you feel any better, I am just as embarrassing about sports in the United States. Also clueless. There is. So it's those kind of things. Am I going to be over or under my sales numbers? Things like that. So discrete buckets. Regression, on the other hand, the second thing is when you are trying to predict values on a continuum or numbers. So this example of predicting prices is an example of a regression problem because what I'm predicting is a number. And even if, like let's say if this was my data set, I would actually, of course, in real life have a lot more data than this because you would want to cover kind of all major categories. But I'd have a lot more data than this. But even if, let's say, 25 or 250,000 wasn't a number that it saw in the training set, it could still, extrapolate between those values and be able to figure out that that's the price, okay? So it's values on a continuum. So that's regression, is it's predicting a number, and you don't necessarily have to have the thing that number in the training set to be able to understand that, okay, this is where it would fall, all right? And then the third one is anomaly detection. So the anomaly detection algorithms are really interesting. So those are useful in the case where you have a highly unbalanced data set. So take, for example, the problem of credit card fraud detection. all right? So in the case of credit card fraud detection, if I look at my credit card transaction database, most of the time you're gonna have a huge number of, real valid transactions. And then the number of fraudulent transactions are very small relative to the size of the whole data set. And then the number of known fraudulent transactions is going to be even smaller still, right? Sorry, I'm trying to like interpretive dance Venn diagram here, but you know what I'm saying? Like, okay, so the known fraudulent transactions are going to be really small relative to that, and so when you try to train a model where I have a ton of data that represent, valid and only a little bit of data that represents fraudulent, that can be really hard to do using typical methods. And so anomaly detection actually accounts for that, where it's like, okay, here's what normal looks like, and then it can help you find things that are outside of that normal, okay? And we have two anomaly detection algorithms in Azure ML. And then finally, the last one, clustering. So this is an example of unsupervised machine learning. With unsupervised machine learning, you don't need to start with a labeled data set like we did with this example on the previous screen. Clustering, for example, you could just have a whole bunch of data. For example, if you're trying to predict genre of movies, what kind of movies, what kind of different categories of movies, you could cluster them together. Here are kind of sports movies, here are romantic comedies, here are action, here's science fiction, whatever. So finding clusters in that sense. Okay? So those are kind of some of the categories that we support. So now, to dive into Azure Machine Learning specifically, I already mentioned that there's 25 different algorithms across those 4 categories of data. And what's really neat about Azure ML is that it's a nice kind of browser-based interface. You don't have to download and install a lot of stuff. You can just go to a website and start getting started. There's a lot of modules to do things that you would want to do in data science. So data cleaning, you can import the data in different ways. You can do different types of massaging. And there are modules in there. Do we have any R people in the house who like R? Okay. Do we have any Python people in the house who like Python? Do we have any SQL people in the house who like SQL? Okay, so there's support for all 3 of those different types of modules in there as well. So if you have a little R script you want to run or a little Python script or a SQL, I actually use the SQL module as well when I want to do like a group by and aggregate stuff. There's support for all of those within Azure Machine Learning. You can drag and drop a little module in there and be able to utilize those languages as well. And then you can create these experiments to train a model and test a model, and I'll show you how to do that in just a second. And then it's literally a button press to deploy them out, and that is awesome, because usually that's the hardest part of machine learning, is the deployment and getting all that stood up. And it's literally button press. You're exposed on a REST endpoint. You're given, it generates a security key for you, and then only things that have that key can call it, and it's beautiful. So I will show you all of that end to end in just a second. Now let's take a look at one possible template for supervised machine learning. There's numerous different ways you could actually do this, but here's one possible way. I would start by importing a data set, and I'll show you how to import a data set in just a second. But let's assume that we have some data set in there, and then we do a couple of different data cleaning modules. Typically, you'd want to repackage your data or do things to it to make it work with the data set that you're using. And then in supervised machine learning, we split our data. And the reason we do this is if I take 100% of my data and use it to train the model, and then I want to see how well my model performs, and I say, okay, model, what is, how much, is a house going to cost if it is 2,000 square feet in the zip code 48075? Of course it's going to know the right answer because it's already seen that. You trained on that data, right? So that's not very compelling. So what you typically do, since you have this nice labeled data set, is you split it and you hold back a little bit of the data. So that way you can train and learn from kind of some part of it, and then let me test by applying this data that it's never seen before and see how well it performs, since we have those known right answers as our labels. Does that kind of make sense? Okay. So we split our data set, and there's different ways you can do that. The industry standard is something like 70-30, where the majority of the data is your training data, and then the 30% or so. You can also do 80-20, or there's something called K-folds as well, where you can do cross-validation and basically take all your data and split it into like 10 chunks, for example, if K was 10, and then take 9 of them, use that as your training set, and then try the last 10% as your test, and then try a different 9 and apply that last 10 and do that 10 different times. That is another method. Okay, But let's say for now, let's say we do a 70-30 split where I take 70% of my data right here from this split. I take 70% of my data, and I apply some algorithm. And again, that algorithm just defines what type of math am I doing to find the correlations between this data. And I train a model based on that data and that algorithm. And then I have this trained model that comes out here, and I take that test data that I held back, so that 30% or however much I held back, and in the score model, what I do is now I feed in just those features, just those inputs, into the train model and see what the model generates. And then I compare that to the labels that are actually in here to see how well it actually did. And then that score model will actually give me a score, which determines your accuracy and how well that is actually performing. And then what's kind of fun is that you can do the whole thing, repeat the same thing right over here next to it. So maybe I do the same thing, only I use a different algorithm. So I'm trying two different algorithms against each other. Or maybe I've landed on one algorithm that I like, but I tried different initial parameters, because a lot of times tweaking the initial parameters can affect your accuracy in a pretty strong way. So you can use that to kind of almost do kind of like a rapid application development thing where you're trying different things, you're testing, you see how they perform, and then iterating nicely. And so then I can take those two scored models and then compare them against each other in an evaluate module. Okay? So that's kind of a template you can use. Now, the one question you may be asking is, okay, Jennifer, maybe that all makes sense, but which algorithm do I use, right? You said there's these 25 different algorithms. If I don't have a machine learning background, how do I know which algorithm to use? Enter the Azure Machine Learning cheat sheet. Yes. So this is an amazing thing that allows you to kind of use a kind of a decision-based process to figure out, which algorithm makes the most sense. And so you start in that big, friendly, yellow thing that says start. And then you start by saying, okay, what is it that I'm trying to do? What's the problem I want to solve? And so one is finding unusual data points. So this is, again, that case of anomaly detection that I told you about. And so if you want to find kind of what's outside of the norm, you can use an anomaly detection algorithm. If you want to discover structure or clusters in your data, you can use a clustering algorithm. And then if you want to predict values or predict categories, you can use these two things. So let's take an example. The problem that we are going to solve today is I have a bunch of demographic information about the passengers on board the Titanic. In case you're not familiar, the Titanic was a ship, and spoiler alert, it sank. Unfortunately, very tragically, it did sink. And so what we're going to try to do is, based on demographic information about people on the ship, we're going to try to predict whether they survived or they tragically perished on the Titanic. So based on things like age, gender, the class of ticket you held, et cetera. So let's take a look and try to do that with the algorithm cheat sheet. So we'll start right here. What are we trying to do? Find unusual data points, discover structure, predict categories, or predict values? We're actually trying to predict categories. We want to see alive or died. So it's not a number, it's a category. So alive or died. So that's actually a category. So we're going to predict categories. Very good. And is it 3 or more or 2? 2, right. There were no zombies on board the Titanic. It was either alive or dead. We had no semi-alive things. So we're going to go to 2 here. And then what's kind of nice in here is that it gives you a whole bunch of kind of information about which ones kind of really shine. So for example, a 2-class SVM that stands for support vector machine. Those are really, really good when you have a really big number of features. They work really well for that. There's other ones you can see. These are really great when your data is linear and they train really fast. The decision trees tend to have really, really high accuracy, et cetera, et cetera. So you can kind of take a look at this and figure out, okay, this gives me kind of an idea of where to start, and you can pick a couple. And I usually start with one linear and one nonlinear one if I don't really know what my data looks like, to kind of see, okay, does this kind of fit into a linear or nonlinear pattern? So that's the kind of look. If you do want to download this yourself and like print it out and hang it in your office like all the cool kids do, you can download it from aka.ms, Azure Machine Learning Cheat Sheet. And then I do have a blog post that I wrote on getting started with Azure Machine Learning, and that has a lot of useful data in it, like where can I find cool data sets to play with. I have links to that. There's an end-to-end Azure Machine Learning tutorial that I linked to from there, and a whole bunch of other kind of useful stuff. And I apologize because I did actually write it for a student audience. So the actual title of the blog post is how to win a hackathon with Azure Machine Learning. But really, after the first paragraph, it's just like how to get started with Azure Machine Learning. So ignore the spin and then just good stuff after that. Okay? All right, so that's some good resources to get you started as well. All right, so now let's talk about the last thing, and then we're going to jump to the demo, and that is data ingestion. So there's actually 4 different ways to get data into Azure Machine Learning. The first one is you can use sample data that we've provided for you. The second one is there's a way to upload a data set from your local machine. So if you have like some Excel data or something that you want to send up, you can do that. Third is you can manually type in data yourself. Don't recommend that one in general. And then finally, you can suck data from somewhere else online into Azure. All right, so let me actually just show you all of those, and then that links to both a blog post and a video of how to do those, so you can use whatever medium you prefer to see how to do that in case you forget later. Okay, so now let's get into the good stuff, the demo. So I'm going to start by just jumping here. Let me show you the 4 ways to get data into Azure, just so that you're all familiar with that. So I'm in Azure Machine Learning. This is the tool right here. It's just studio.azureml.net. And there is a free tier if you want to kick the tires. So I'm going to start by clicking that little plus, and I'm going to do a new experiment. Now, I don't have time to go through all of these, but there are so many cool experiments here. Like, I totally recommend coming back and perusing these at your leisure. There's all kinds of stuff like how to do like CRM and predict whether people are going to, like this one is predicting whether someone might have breast cancer based on some health data. There's a credit card risk one. There's a Twitter sentiment analysis. And these can be great jumping off points if you're like, hey, I'd like to do that with my own data. Grab that one as a starting point, then import your own data instead, and then you can do some really fun stuff. Flight delay predictions, there's clustering, there's all kinds of good stuff. So check those out when you have time. But I'm going to start with a blank experiment because I want you guys to see how to do this completely from the beginning. And so I mentioned there are 4 different ways to get data in. So the first one is to use sample data. So I'm going to go here to samples. You will see under Save Data Set, there's a samples, and there's all of this fun data to play with that we give you as sample data. So there's this adult census income. So given demographic information about adults, do they make more or less than, I think, 50 grand a year? There's some automotive data. There's this bike rental data from the University of California, Irvine, which is very famous. A lot of people use it for machine learning. There is an RGB image of Bill Gates, in case you want to do fun facial detection stuff. There is some blood donation data, book reviews from Amazon, breast cancer data, CRM data, flight delay data. There's German credit card data. Oh, there's actually some movie data from IMDb and some restaurant data from Yelp. So if you want to do like recommendation engines and play around with those, you can get started there. So there's a whole bunch of good stuff in here. So check that out too. So if you just want to get started, that's one way to do it. Okay, but the second way is, let's say I wanted to upload data from my own machine. The way you do that, and this is kind of the trickier one because most of the other things are all live in here. If you want to upload data from your own machine, though, you do new data set from local file and upload it there, okay? And then you can just browse on your own machine and then grab data from wherever and give it a name, select the type, and we support CSVs, TSVs, plain text, SVM Lite, a number of other different ways, our data, et cetera. So you can support all those and then give a description if you want and then upload that, and it will upload it up to Azure for you. The next way, the 2 remaining ways are under data input and output. And by the way you use this data then is just drag and drop it into the space. So you can do that. And then once something is uploaded, the way that I just said, using new data set, it will actually show up here under my data sets. So I could take, for example, this manager lie data and stick that right there, and you can use that as well. And then the other 2 ways are here under data input and output. So there's this enter data manually that I mentioned. So if we take a look at that, if I click on this, so this is actually, this properties pane is contextual. So no based on what you have selected here, the properties will pop up. So in this case, if I wanted to do a CSV and I have this has header checked, I could do something like those things where I'm predicting square footage, number, bedrooms, and price, or something like that, and then give it some numbers, whatever, 4 bedrooms for some amount of money, whatever. So you can do all this. Now, you need a lot of data to do machine learning effectively, so I do not recommend using this. What you would use this for is for 2 things. Number 1, it's great for demos, so nice for me. So you can use it very easily to do a quick demo. Number 2 is it's really good for like quick lookup tables, right? If you're doing some kind of like flight delay data and you want to say that BNA maps to Nashville, Tennessee, and I apologize, I don't know all the airport codes in this area. AK, what is Auckland again? AKL? AKL maps to Auckland, and these kind of things. So you could do a quick lookup table here and kind of enter that in quickly, and that can be useful. So it's really great when you just want to, ooh, let me do a quick something and get a small data set in there. So really good for that. So that's when I would use it. All right? And then the fourth way is this import data. And this is when you have data that lives somewhere else online and you want to suck it into Azure. And so here is this import data thing, and you can see we have the ability to import from just a generic web URL using HTTP. We can run a Hive query, so if you're playing in the big data space and you want to pull from like a Hadoop cluster, for example, you can use a Hive query there. We can pull data from SQL Azure, from Azure Tables, Azure Blob Storage. There's a preview feature of using on-prem SQL database, and then we also support a generic OData feed provider. So a lot of other things we just can suck in through OData, okay? So all these different ways to get data in. All right, so now you have seen the 4 ways, so I'm going to go ahead and delete this, and let's get back to solving the actual problem that we want to solve today, which is predicting the fate of the people on the Titanic. Now, just before we get started, how many people are familiar with Kaggle? Anyone know Kaggle? Oh, you guys are in for a treat! Okay, so Kaggle is this awesome website. It's kaggle.com, and it's Kaggle. K-A-G-G-L-E, Kaggle. And so you go there, kaggle.com, and then click on competitions, and it takes you to this site. And this is an amazing site that gives you all of these competitions for machine learning. And so the reason I love this is that if you just want to get started with machine learning and kind of do some cool stuff, there's kind of 2 problems. Is number 1, you need a cool problem to solve, and number 2, you need the data to solve it with. And those are usually the hardest things to find, right? Kaggle gives that to you, right? So Kaggle has all of these challenges, and a lot of them now, it's gotten popular enough that a lot of these are sponsored by like big companies. Like Bosch, for example, is like one of the automotive suppliers in the US, and so they have something, and there's a prize of 30 grand for whoever wins this competition. And so they have this information on reducing manufacturing failures, and then there's some other things about predicting recommended content that people will click. And Melbourne University is sponsoring something. So there's all these cool things that you can go, and then any one of them, Allstate, so claim severity. So if you click on any of these, what it gives you is the problem that you're trying to solve. So it describes the problem. Uh-oh, this is running a little slow. Let me start a new window if we're going to run that slow. Competitions. Okay. Here. So here's the Allstate. Well, Allstate one still isn't loading. Okay. So let me go down to the one. We'll come back to that one and see if it loads in a second. But this one, and some of them are actually jobs. So the Allstate one, what you win is an interview with Allstate. So the winner actually, so some of the companies use that because Facebook has done this, Yelp has done this, Microsoft has hosted things up here. So it's kind of cool. All right. So what we are going to do, though, so if you want to go home and do this yourself afterwards, and I'll tell you some things that I'm actually not going to implement today, but that will help make your model better. You can go here to this Titanic, Machine Learning from Disaster, and get the exact same data set that I'm going to be using. So all of the competitions are set up like this. On the first page, it shows you these competition details. So here's the details of the competition. So in this case, ship, Titanic, sank. You want to predict whether they survived or died. So all of that information is here, and some information about the Titanic, a little background. And the second thing is where they give you the data. So in this case, here's all the data information, and then a little more information about how it's set up and what each column means and stuff. And then the third one is making the submission. So it tells you kind of the format of how it accepts the data, and then you can actually make the submission. So kind of cool. All right, so now we are going to just take that exact same data set, and I've already downloaded this data from that website, and I've already actually uploaded it here, just the way I showed you before, using new data set. I've already uploaded it into my data right here. And so I'm going to use this Titanic training set to be able to do this. And so now, what I'm going to do is just kind of show you this data and kind of do a massive brain dump of here's all the things that I would think about when I'm looking at this data and deciding how best to do data cleaning on it, okay? So I'm going to right-click on this node and hit Visualize, and we're going to kind of talk through. I'm just going to do all the talking first and talk through each column and how I would mess with it, and then we'll go back and actually implement all that in a second. All right? So let's hit Visualize and kind of talk through all of these things. So you can see there's actually 891 rows in this data set, so we get a sense of the size of the data set, and then the number of columns as well. So let's take a look at each one of these things. So the first one is passenger ID, and just by looking at the beginning, 1, 2, 3, 4, 5, 6, this looks like a randomly assigned integer to each row, but we can confirm that by going over to these statistics on the side. Since I have passenger ID selected, it's doing statistics on that row. And you can see the mean and the median. I can see that the minimum number is 1 and the maximum number is 891, which is the same as the number of rows in the database, and that there are 891 unique values. So yes, in fact, that has confirmed that this is just a randomly assigned integer. So usually, if it's just a randomly assigned integer, I would want to throw it away. And actually, in general, when you have a data set that is a certain number of rows and the number of unique values is the same, in general, you want to throw that away because it's not going to be very useful. If anything where the size of the data set has the same number of unique values, it's probably not very useful. And the reason for that is you wouldn't want to build something like a decision tree that says, if passenger ID is 7, then they survived, because that's not something that extrapolates well, right? Does that make sense? So that's why you wouldn't want to do that. It overfits the data. Okay. So what we're going to do is instead, normally I would throw this data out. However, with the way Kaggle works, the actual submission process is they want the passenger ID and then the prediction is all they want. So that means I need to keep the passenger ID associated with each row and send it through without using it as a feature. So let me show you how to do that, okay? I'll show you how to do that in a second. So that's what we're going to do with that row, or that column, sorry. All right, the next one is survived. So this is my, one thing I would want to change is right now it's listed as a feature. This is actually my label, right? This is the thing that I want to predict. I want to predict whether they survived or died. And in this case, if you look at the data explanation, 0 actually means they did not survive and 1 means that they did. So we want to use that data, and there's actually an interesting histogram right here. You can see in this data set, 62% of the people tragically perished and 38% survived. So you can kind of get a sense for the relative proportions there. So what we're going to do is we are going to change this from a feature into a label, is one thing I see that I'd want to do with this. The second thing is right now it's numeric. And there are some cases when a number isn't really a number. You don't really want to treat it as a number. And let me give you an example. Imagine we're back on the predicting housing prices thing, and we're using zip code, right? Do you guys have zip codes or something comparable to that in your addresses? Okay. So there's some kind of zip code or number that represents a location in an address. And in that situation, that's a number that you don't really want to treat as a number, right? Like, would you want to average those together or try to do math on those? Like, no, that doesn't make sense because it's not really a number, right? It's like an enumeration, right? Thinking of it in developer speak. It's a number that represents something else. So when you have numbers that are like that, it oftentimes makes sense to make those categorical variables, all right? So they're not numeric, they're categorical, and that means that we're going to treat it like discrete buckets as opposed to values on a continuum, right? Because zip codes aren't actually values on a continuum. They represent Auckland, New Zealand, and Sydney, Australia, and all the other things, okay? All right, so we're going to do that. So I'm going to actually change, so that's what I would want to change here is I would want to make this categorical from numeric, and I would want to make this a label, so we'll do that. The next is the passenger class. So this has, you can see 3 unique values. So first class, second class, and third class passengers. You can see from this data what it is since we have our min and our max right there. And so I am actually going to leave that data in. I think that is relevant data for predicting whether or not someone would survive or die based on all of my historical knowledge of the Titanic, which came from the movie Titanic, and people standing at the gate saying, "Let us out, you can't keep us in here," right? And when all the first class passengers are boarding and they have the gates closed on the third class passengers and all that thing. So I think this is actually going to be relevant, right? So we'll test that hypothesis by leaving that in there. So I'm going to leave that in. I do think that's a relevant feature. And then I'm going to change it from numeric to categorical because it's more of a experience, right? You have a distinct, first class experience, second class experience, and third class experience. So I would make that categorical as well. All right, the next thing is name. So again, with our 891 rows we have here, there are 891 unique values for names. So again, that should be a warning sign that that's not actually going to be useful, and you don't actually want to create a decision tree that says, if the name equals Jack Dawson, he's going to die. That sort of thing, because again, it's not going to extrapolate well. So I'm just going to choose to throw this data out. Now, for the machine learning purists in there, yes, there might actually be some signal in here. If you wanted to do some research and look up, what are the Richie Rich names of that day, the Vanderbilts, if you will, and the Kennedys or whatever the big, fancy names are, then maybe that would be relevant. So you might be able to extract some signal out of there, but for a 1-hour demo, we're going to throw that out. Okay, so we're going to get rid of name. All right, the next category is gender. And so in this case, kind of interesting histogram to see the male to female ratio on board the Titanic, 65% male and 35% female there. So in this case, it's a feature. I do think that's a relevant feature, right? If they did board the women and children on the lifeboats first, then maybe you had a better chance of survival as a woman. The one thing I would change here is that it's being treated as a string right now. Male or female is being parsed as a string, and we don't actually want to do text analytics on the word male and female, right? So we don't need it to be a string. We can make it just a categorical variable, so kind of 2 enumerations of your male or your female, right? So I'm going to make that categorical as well from a string and leave that as a feature. Good. All right, next is age. So age is a feature. I do think age is going to be relevant too, because it is a, they boarded the children first and that sort of thing, so I think age probably would be telling. So I think that does make sense as a feature. And for right now, I'm going to leave that as a numeric. There's actually some more interesting things you could do there. So if you look at kind of the histogram of how people, the distribution here, you actually have, the lowest thing was unfortunately the 0.42, so a baby less than 6 months old aboard the Titanic, which is very sad to think about. And then you kind of have these children, like this category of children right here, and then you kind of have like the adults right here, and then like the elderly right here. So just kind of distributing that kind of into those chunks, you could almost do an enumeration of here's kind of the child experience, the adult experience, and the elderly experience, and that actually does kind of align to survival rates. So you could change that into an enumeration or do some other interesting things with that. But for right now, we're just going to leave it in there as numeric. That's just something fun you could do later. Okay, the next 2 things are actually, this SIB-SP stands for sibling or spouse. So did the person have a sibling or spouse on board, and if so, how many? And so the maximum value is 8. Somebody had 8 siblings or spouses, I guess. And then the other thing is parent or children, and so someone had 6 children, for example, in this case. So these 2 things I do think these might actually be useful, right? I know if I was on the Titanic and I have just 3 children, but knowing my children, and especially my little boy, he would be jumping overboard like the first sign. So if someone had like 6 children or 8 children or some of these large families that we're seeing, I'm wondering if maybe the husband was more likely to survive if he was part of this family unit, because if there's like, all these children running around, maybe the man was allowed to come and help like contain them, like mine would have needed containing, but I don't really know. So you could actually do some interesting stuff here with maybe changing it to a 1, like just kind of parsing this and saying, okay, make it 1 if they're part of a family unit and 0 if they're not, or some other stuff. So there's ways you could actually massage this. For right now, I'm just going to leave it in as a numeric feature and kind of go the simplistic route, but there's other interesting stuff you could do with that, parsing out families. All right, the next thing is ticket. So this is the actual ticket number, and can we just explore this for a second? Let's take a look at the first ticket. It is a letter, / a number, space, more numbers, okay? Then the next one is 2 letters, a space, and a bunch of numbers, okay? Then we have 4 letters, / a letter, a number, a period, which came out of nowhere, and then a bunch of numbers. Then we have just numbers. So whoever wrote this ticketing system, like what the heck? How am I supposed to parse that, right? Okay, so whatever, but okay, that makes me crazy. So we're going to throw that out, partially because I don't think your ticket number is relevant, but secondly because I don't want to have to deal with that nonsense. So that's what we're going to do with ticket. Ticket is not going to be valid right now. Again, it's a string, but we're going to get rid of that. Fair is the next thing, and this is actually kind of interesting. If you look at this data, okay, so the minimum fare that anyone paid was 0, like that young ruffian Jack Dawson who gambled his way onto the ship without paying anything. And then the maximum fare someone paid was $512. Okay, so I understand there were first, second, third class experiences on board, but still, there were 248 unique values for tickets, right? Okay, so this reminds me is if, on modern days, if someone needed to, for example, book a trip to New Zealand, and so she looked at prices and she saw, okay, here's a cool, kind of a good price for like, you know, maybe $1,500, okay, let me just go talk to my manager, make sure that's okay, then go talk to my husband, make sure we can line up daycare, make sure that all works, come back, and then the next day it's like $3,000, and you're like, ugh, supply and demand, why do you do this to me? These websites, they know when you need it. Well, it's nice to know in those scenarios that they were still doing that in the days of the Titanic. This is not a new thing. Very interesting. Okay, so in terms of fare, I do think this is relevant, so let's leave that in as a feature. I think this is something that would contribute, because probably if you paid more, it will correlate to a nicer experience, and you probably are more likely to survive. So we're going to leave that in, and we're going to leave that numeric for right now. All right, the next thing is cabin. Now, cabin is actually very useful, I think. But as you can see, there's a lot of missing values. So a lot of people didn't have cabins, right? There was the bottom floor where they were all Irish dancing together and nobody had their own rooms. That experience. Or there were some cabins where people were, painting themselves wearing naughty necklaces and such. So in these scenarios, you can see that may contribute to whether or not you survive. So you could do a couple things here. Number one, you could change it to like a 1 or 0, make it binary for whether or not they had a cabin or not. And if you're really bored on a Friday night, you can actually download maps of the Titanic and like optimize for like how close they were to the edge to the lifeboats. Like what are the ones that were like on the top level, and then what are the ones that were closer to the middle, and then as you go down. So there's actually some really cool stuff you can do there. If you wanted to. So it's really cool. But unfortunately, since I need to be done in like probably way too soon, we don't have time to do that right now. So I'm going to choose to throw it out right now, but just you can go back and actually do that later, and it's pretty cool. There is some signal in there. Okay, and then the last thing is embarked. So I did not know this prior to playing with this data set, but the Titanic actually stopped at 3 different ports before it started across the Atlantic. So if you go back to like Kaggle and look at these things, you can see there are actually 3 ports right here, and then they're represented by C, Q, and S right here. All right. So what we have, if you take a look at this data too, it's kind of neat. If you look at the histogram, you see that actually the majority of people boarded at Southampton. So sometimes it's kind of cool to like know what that data looks like, because, for example, in the case of like missing values, you could probably fill in Southampton for the missing value and probably be okay for those kind of things. So anyway, interesting. So in this case, what we do have is a string feature. I am going to leave it in as a feature. I don't actually know if it's relevant or not, but let's leave it in and let the machine learning algorithm tell me if it's relevant or not. And then I'm going to change it from a string to a categorical, right? Because it's not, we don't want to do text analytics. It's just categories, right, of these 3 different ports. Okay, so that was the data dump of everything I was thinking about when I looked at that. Now, let's go back and actually implement all that stuff that I just said. Okay, so we have this training set. Now we want to do all that data cleaning that I just mentioned. So I am going to start by going to this data transformation section. And in real life, I use this very rarely. I'm trying to do it right now just so you can see it. But usually what I do is the search. If you find out, once you kind of learn what the names of the different modules are, it's faster to just like search for them like this and say project columns, for example, and then grab this select columns and data set right here. But you can do it, but these things do all exist kind of in the same place, but just to give you a sense. Right here, so I was doing data transformation under manipulation. You can see some of the things that are possible, applying SQL transformations, cleaning missing data, editing metadata, joining things, etc. So what I'm going to do is I'm going to start by modifying some of the things that, or getting rid of the columns that I said I was going to get rid of. So this is select columns and data sets, allows you to filter out some of those columns. So I select this, and then this is contextual, so I can hit the properties on here and launch the column selector. And I said I was going to keep passenger ID, but we have to remember to not use it as a feature, so I have to go back and do that. Survived, yes. Passenger class, name, Gender we want, age we want, oh come on. Sibling, spouse we want, parent, child we want. Oh, actually name. I said we don't want name, forgive me. So name is not in there. Ticket we don't want in there because that is gobbledygook and not formatted. Fare we do want. Cabin we're going to throw out because it's there's not time, but that is actually useful. And then embarked we're going to keep in there. So passenger ID, survived, class, gender. Okay, I think that's pretty good. Okay, so we're going to do that, and so we'll only carry these forward, and we're going to throw out these things for now. All right, the next thing I want to do is this edit metadata. So what this is going to allow me to do is kind of modify some of these other things that I was mentioning. So I just kind of wire up my data flow like this to connect them all up. And then the next thing I want to do is you can select some columns and then apply changes to those columns. So let me start by deactivating that passenger ID before I forget. So here's the passenger ID, and by default, everything comes in as a feature, right? It was treating everything as a feature by default. And this was something that we wanted to pass through, but we didn't want to treat it as a feature, remember? Because we don't want the algorithm to say, you know, if the passenger ID was 7, they survived. So what I'm going to do here is you can see the things that you can change on the metadata editor. You can change the data type if you want to make it a different data type. This can be useful to change like date times to like ints or something that it's easier to do math with. Here's making something categorical. We'll do that too. Here's the fields. So in this case, what we want to do is we're going to hit clear feature. So what that will do is keep passing the data through, but it won't use it as a feature. All right? So I'm going to hit clear feature for passenger ID. So now it'll be through, and then you can also rename the columns right there as well. All right, good. So now the next thing I'm going to do, and I have to use a different thing for this because I want to select different columns, is that categorical. Remember there were some things that we wanted to make categorical? So I'm going to change, select some columns and make them all categorical. So the things that we wanted to make categorical were, passenger ID is actually gone at this point, so that, or it's doesn't matter, so that's okay. Survived, we wanted to be categorical. You can actually start with all columns or no columns as well. By the way, I'm starting with no columns and just adding the things I care about, but you can reverse that if you want to. So this is not, doesn't matter. This I want to be categorical. The class I want to be categorical. Name is actually gone at this point. Once I run it, if I ran this at this point and it had already done that, then it wouldn't actually show up in here because it would see that it was gone. But since I haven't run it yet, it's not showing up. Name is gone. Gender I want to be categorical. Age I want to stay numeric. This I want to stay numeric, numeric. Ticket's gone. Fare should stay numeric. Cabin is gone. And then embarked I want to be categorical. Okay, so I think those are the things that we care about. So I've made all of those discrete buckets, right? What else do I need to do? Oh, category, so I need to make survived has to be a label, right? Because that's being treated as a feature right now. So I'm going to hit that. And then let's change that from a feature into the label, so we know that that's the thing we're trying to predict. Okay, I'm going to save that. Actually, let me change it, the name to a better thing. Let's call this Ignite NZ Titanic, and then save it. All right, and then let me just test it. Let me just run it and see where we're at. So I'm going to hit run and let that go for a second. And Azure Machine Learning actually only charges you when it's running. So all that time we spent designing and such, no charge. When it actually charges is right now the running. And it did finish running, so we're good. So let me just right-click on this, hit visualize, and see if everything is going according to plan. All right, so passenger ID. It is numeric and it is no longer a feature. Good, that's what we wanted. This should be a categorical label. Survived. Yes, categorical label. Good. Passenger class should be a categorical feature. Good. This should be a categorical feature. Good. Numeric feature. Good. Sibling spouse. Numeric feature. Good. 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 And then categorical feature. Yes. Okay, good. So I'm happy with all this. So now we've done our data cleaning and data processing, and I think it's at a state where it can be, you know, somewhat useful. So now what we're going to do is split our data. Right? We talked about how you want to kind of make that data, have it do something useful. So I'm going to grab data split and split it right here, wire this up. And now I'm going to split. There's different ways you can split. You can split by regular expression and other such ways. I'm going to split the data 70-30. So let me, this is the fraction of rows that you want to send to the first output node. So I'm going to split 70% right there. You can change the random seed if you want. And then stratified split will say if I wanted to split like the people who died and survived evenly, you could like choose that as the stratified split, and then it would try to do that in proportions. Okay, so then what I want to do after I've split is train some models. So let's go here to train model. And I'm going to actually build two at the same time, so I apologize if this is a little confusing. But I'm going to train two different models at the same time, and I'm going to send my training data into both of them. Note when I grab this that, see how one of the input nodes goes red and the other one goes green? That's using the typing to say, okay, this is the one that accepts data, and that's the one that actually accepts an algorithm. So this tells me, okay, this is where I want to send it, and helps you remember what's what. So those accept a data set, cool. And so now I'm going to choose two different algorithms to use. So let's go down to, to machine learning. So I'm going to open up my machine learning and initializing some models. And we already said that this was a classification problem. And it's not a multi-class classification. It's a two-class classification between alive and died. So let's grab one linear and one nonlinear one. So maybe a logistic regression, for example, as a linear one. Bam. And then we'll do maybe a decision jungle is slightly more efficient. So we'll do that for our other one. And so now we have two different models that I can try. And note that you can, if I click on one of these, see all of the great parameters you can tweak. So you can tweak all of those parameters to customize it and have it work even better for your scenario. Then what I'm going to do next, and then in the train model, you see that it has a little red mark that says, hey, there's something you need to do. So I select it, and it's asking me here, what is your label column? So if I launch that, I can say survived is what I want you to predict. And then same thing over here. I'm going to predict survive. That's my label. Then finally, I'm going to score these guys. So there's actually scores right here. So I'm going to do two score models on each of these different models that I'm building simultaneously. And so I do score right here, score right there, passing those in, and then I have to, what data am I using to store? I'm going to use that 30% of the data that I held back. So I'm going to pass that data in right there and right there in those two different spots. So now it's using that 30% of the data. It's taking the model that I built here, and then it's testing it against that data I held back. And then to compare those two against each other, I can use an evaluate module where I have one evaluate and then compare how the logistic regression does against the decision jungle. All right? So I'm going to go ahead and save that, and then let's run one more time to finish it. And another thing that's kind of neat about Azure Machine Learning, because since it does actually charge based on the time, it does cache everything. So since I didn't change anything up top, it should just go, see how it already just went bam, 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 bam on all the top things, because it had cached all those, so it doesn't like rerun them. Okay, it doesn't charge you again for something that's already been run. It does cache that, remember it, and then it only runs like the new stuff. And now if you had made a change up there, then it would have to rerun it. But since we didn't make any changes up there, it just did that. Okay, so this will take just one more second. Bam, bam, bam. And then once it is done, we will see the results. And I will right-click here, and that was just too efficient. I didn't even have time to get us in the mood with a little music. Okay, so if you look at this, let me show you how to interpret this. So this chart right here is called an ROC chart. So this is the true positive rate versus the false positive rates. So true positives are a good thing, right? That's when it thinks it's a positive thing and it really is a positive thing. False positives are bad. It's when it thinks it is and it's actually not. So perfection would be 0 false positives, right, which on the chart would look like this, going straight up this side, and 100% true positives, so along this side. All right, so a curve that hugged this side all the way would be perfection. And it's really hard to see on projectors always, but there's a kind of a diagonal gray line across the middle. That's 50-50 random chance, a monkey flipping a coin, right? So if your algorithm does not do as well as that, start over. There's a problem. And you can see in this case, we did better than 50-50 random chance. We didn't get like all the way hugging this side, but we did okay. So let's take a quick look here at the first one. So this is, I have the blue selected, which is the one that didn't do quite as well, because you can see this one is a little bit underneath. And that was my logistic regression. And this one, you can see the false positives. It gives you the true positives, true negatives, false positives, false negatives, all of those things. And then you see we have an accuracy of about 79%. And some other things. And then if we compare that to the other one, so this is our decision jungle, which was a little higher here. You can see this one actually had an accuracy of about 81%. So if you kind of want to break down all of this data, true positives and true negatives, you want those to be high, and they are decent. And then false negatives and false positives, you want those to be low. Accuracy, you want it to be as close to 1 as possible, so accuracy of 81% is pretty good. And the precision and recall are good things to think about too when you think about like how well is this model going to extrapolate, right, across a bigger data set. Things like that can help you get a sense. And then F1 score is actually a combination of precision and recall. And then this AUC stands for area under the curve, which is a combination of like all of those, okay? And so you can see that's about 85%. So that's not too bad. And then we have binning down at the bottom too to see how it does with kind of each of the individual things. So if we take a step back and think about that, we were getting accuracies just using really fast and dirty mechanisms with me talking my ear off in less than an hour. We were able, and not modifying or tweaking any of those initial parameters. I was just using default values for everything. We were able to get an accuracy of about 80%. Right? That's kind of cool. What if you could predict 80% of the time that somebody was going to click an ad on your site? Or 80% of the time know when something was, what your sales numbers were. Like that's pretty good, right? So there's a lot of times, this is fairly simple problem. So in real life, things can be a lot messier. But it's kind of cool to see the things that you can do and the possibilities that are out there. Okay, so now let's do the final step, which is, let's say I'm happy with this. I think I'm going to choose my decision jungle. So I'm going to click on that train model to let it know that this is the one I want to use. And then I'm going to say, okay, I want to go ahead and stand up a web service. And I'm going to select this predictive web service. There's also a retraining web service. So what that will do is stand up another endpoint, and you can call that endpoint if you want to send it more data and retrain your model. So over time, you might want to retrain it with fresh data. So you can do that programmatically as well using a retraining web service. But we're going to do a predictive web service right here. So I'm just going to click on that. It's going to run, and wait a second, don't miss it. Ooh. Cool animation, right? I hope somebody got a bonus for that. So here's, let me show you what it actually just did. So what we actually did was we added a web service input and output on either end. So now there's kind of the, how the web service hits our thing. You can see the Titanic data set is still there, but it's grayed out. The reason it's still there but grayed out is that it's using the metadata on that. So the column names and column data types, it's using that information, but it's not using the actual data anymore. So that's why you still see it, but it's grayed out. It's just for the column metadata. Then it's doing all of the same things. Select columns and data sets. So it's doing all of the same data cleaning that we left in there. All of that is still in there. But then the splitting and all of the stuff we did to just test our algorithm is no longer there. All right, so we did get rid of that. And then all we have now is the scored model that we built, which is right here. And then it just goes into a scored model. It passes the data in from the web service and then exposes that at the end. All right, so fabulous. So now we have that. So I'm now going to, you actually have to run it once just to make sure that everything worked okay. So I'm going to do a quick run there, and then we will deploy it. This usually is really fast, so this is probably not even worth going over there. Oh, darn it. Oh, well. All right, so deploy service. So there's a couple different ways. I'm going to just do the classic for now. There's a new web service that allows you to select the tiers that you want to use, so how big of a machine and how you can specify various things for how hefty of a machine you want. But I'm just going to use the classic one right now just to show you some stuff. And there's two different modes. So let me just show you this real quick because I love what they did here. So first of all, it stood up a web service endpoint. So we have an endpoint. It also generated an API key for us. So here's my API key. So you need this API key to call the web service. So once you have that, you can call it. So you got kind of your security baked in for you. And then this API help page, I think this is a thing of beauty. So if I just open this in another thing, there's two modes you can call, request response or batch execution. Request response is if you want to say, hey, here's individual information about one passenger on the Titanic, and then get a response back around that one person. Or batch execution is, let me just send up like a whole CSV of information about a bunch of passengers, and then get back a whole bunch of responses. So you can choose what makes most sense for your data set. But then, if you look at this API documentation, like I just think this is awesome. So here there's actually sample code generated, and I will show you that in a second. But if you don't have the sample code and you want to use a different language, it gives you all the information you need to build this yourself, like super easy. So first of all, here's what the request looks like. Here's the exact post message that you would call. Nice. Here are all the exact headers right here. Here's what a sample request would look like, passing in all these column names and some values that it figured out. Here's what the response looks like. Here's all of the column types, all of the data types, everything that it figured out from your data. Here's the input parameters. Oh, and here's the output parameters. Oh, and here's the allowed values, which it figured out from your data as well. So if you get confused on the gender column, is it F or M, or is it actually female or male, and what's the casing and all that stuff, it tells you like right here. So basically, you could build this and then point your developer friends to this without even having to talk to them and say, here, just go build it based on this page, and done, right? It's so nice. It gives you all the information. And then if that's not enough, it gives you sample code in 3 different languages. So here is the actual code. So for the C#, you can just copy this, open up a new console project, hit paste, then hit run, and it pulls down some NuGet packages, and then it just works. And it's just beautiful, right? So C# is there. We also have Python and R. And then if you don't like one of those 3 languages, cool, you have all the information up there above to build it yourself in Ruby or whatever language you want to use. Okay? Cool? Cool. So that is, the documentation is just really nice. Now let's actually test it. So there's a couple different ways we can do to test this. So let me hit test. So let's actually try this out. Let's see how well it works. All right. Remember, there was less than 1,000. So let me say passenger ID 1,000. Let's use some new data, 1,000. And let's test if they're going to survive. I'm just going to leave that blank since we don't know yet. Let's use a first-class passenger whose name was Rose, and her gender was female. And how old do you think she was? 21-ish? 20? She looks, yeah. I have no idea. Siblings or spouses, she wasn't technically married yet, although she was cavorting around like she was. She was engaged. She was engaged, but she was not married, so I'm going to leave that as a 0. Parents or children, she did have the mean mother, right, that wanted her to marry the rich guy for his money, so we'll put 1, since she did have a parent. Ticket number, I can essentially just bang on the keyboard because that's horrible. The fare, so the max fare was like $512, and she was pretty well-to-do. So I'm guessing she paid at least $350, right? Maybe more, 400, should I say? I don't know. And then cabin, we did know that she did have a cabin. So let's just give her a cabin number right there. Okay. Now, and the embarkment point, I have no idea, but let's just stick in Southampton because it was the most common one. All right, now I'm going to hit OK. It's going to call that, and I already got the response back, so test return. So by default, it returns in all of the data that you passed in, it returns back. You can actually stick in another select columns and throw out all the stuff you don't care about before the web service output to get rid of all that. But by default, it gives me back all of the stuff I passed in, and then it adds on 2 things at the end, which are survived or died. And in this case, it does predict, yes, 1, that she did survive with 98% accuracy, confidence in that. So 98% confidence that, in fact, Rose did survive the Titanic. All right, so we could actually do the same thing for Leonardo as well, if we wanted to. I'm sorry, Jack Dawson. But one thing, since we're almost out of time, I'll skip that. One last thing I want to tell you is these Excel spreadsheets, these are awesome. So if you are working with a business analyst, or someone who's not a developer, right, and you want them to be able to use your web service, this is an Excel spreadsheet that is already wired up. It has the API code in it, and basically the columns correspond to the features in your data set. So you can just put in, like it's an Excel spreadsheet, and you just put in all the information about the different people, or like the passenger information, and then it calls the web service for you, and in the last column, it actually shows you the prediction. So someone who doesn't know how to code can just take that and then type the values in Excel, and then bam, it just calls your web service and is awesome. So that's really, really good for like the business analysts or non-coders in your group. Okay? Okay, whew. I think we covered everything. Right? They're really, really fast talking. All right, so that was the demo. Hopefully you learned a little bit. How many people learned something today? And hopefully it didn't involve just information from the movie Titanic. Okay. That was the demo. Here is there is the chance to win a Surface Pro 3 or an Xbox One S, so please, please, please. I did not get to see the glowworm caves and the Hobbit place yet, so I really want to come back. So can you please evaluate this, and if it was useful, awesome. I would love to hear that feedback so that I can see the Hobbit place really badly. And then this is my information if you have any other questions. Thank you.